Good afternoon, all of you. So today we will learn amplitude modulation. Yesterday I sent you some previous year JEE questions. You can try those problems. You try only those problems which concepts we have learned already. Okay, that problems only you try. Go on, try. Okay. Now next one, that is amplitude modulation. Amplitude modulation. Okay. So what is the amplitude modulation? See here. The process of changing the amplitude of a carrier wave in accordance with the amplitude of radio frequency signal. Okay. Now you see here, I'm showing you diagram of this signal. This is what the modulating signal. What is this modulating signal? And its amplitude is AM. Okay, clear? Next one, another one is carrier frequency or carrier wave, we can say. Carrier wave will have high frequency, yes, no? So you see here, this is what carrier wave. And it has, let us suppose, amplitude AC. And the third one, this is what modulating signal. Okay. Now, let's learn this with equations. Now, first one, I am taking carrier wave. Carrier wave is denoted by C of t. What is carrier wave denoted by? C of t, and that is equal to AC sine omega c t. This is wave equation of carrier wave. Next one. Next one is modulated wave or modulating wave, we can say. This is, I am denoting with m of t, and this is equal to am sine omega m t. So omega c, we know omega c should be what rate? 2 pi fc, and omega m should be what? 2 pi fm. This is just angular frequencies, we can say. That is for carrier wave and modulated wave or modulating wave. Yes. Now what to do? See here. This modulated wave will be like this after mixing. That is, we have to mix this amplitude of carrier wave with this am of sine omega mt into sine of omega c t. Okay. Now see, what I am doing. I am just multiplying here. So see here, AC sine omega ct AC sine omega ct, just multiplication, plus am what you will get, see, am sine omega mt into sine omega ct. Okay, clear, understood? Now what we got, see, AC sine omega ct, AC, this is nothing but for carrier wave. So Cm of t is equal to AC sine omega ct, AC sine omega ct plus am sin omega mt, am sin omega mt into sin omega ct, sin omega ct. Okay. Now what I am doing, if I am taking AC common, what I am doing, if AC I am taking common, what we are getting, see, AC common into bracket sin omega ct plus, here there is no AC, so that's why am by AC into sin omega mt into sin omega ct. This am by AC is called modulation index. Here mu is equal to am by AC, which is also denoted by ma, is modulation index, and therefore Cm of t is equal to AC into bracket, or even if you will remove this bracket also, AC sin omega ct plus mu into AC. Yes, no, because this mu and this AC, mu into AC, sin of omega mt into sin of omega ct. Clear? Now let's come back here. Okay. Here I am writing one more line. To avoid distortion, mu should be less than or equal to 1. Okay. And now let's come back here. This is formula sin A into sin B, which is equal to, below, 1 by 2 cos A minus B minus cos A plus B. Is that clear? Sin A into sin B formula I am using. So I am getting Cm of t is equal to AC sin omega ct plus mu AC into 1 by 2 into bracket cos of omega m minus omega c into t minus cos of omega m plus omega c into t. Yes, no? Clear? Yes? Understand? And then I am getting like this, AC sin omega ct plus mu AC by 2 cos omega m minus omega c into t minus mu AC by 2 cos omega m plus omega c. But here always omega c is greater, no? So what I am doing, I will keep here as a omega c. Okay, here I will keep omega c. Omega c minus omega m. Yes, why? Because carrier frequency is high, no? So I will keep omega c and omega m here. Okay. Omega c minus omega m. Here also omega c plus omega m. Here also omega c minus omega m, and here also omega c plus omega m. Okay. Now this one, omega c minus omega m and omega c plus omega m is called as what we are calling it as a lower sideband frequency, and this is what upper sideband frequency. Okay, what is this? Lower sideband frequency and upper sideband frequency. Okay, omega c minus omega m is what? Lower sideband frequency and upper sideband frequencies. So US LSBF and USBF. Clear? Got it? On these problems you are getting. Okay. हाँ यस, नो डिफरेंस है फिर भी, लेकिन ये जो मुझे नीचे चाहिए ओमेगा सी माइनस ओमेगा एम, वो मैं लो निगेटिव साइन ना आए इसलिए. ओके. राइट. तो ओमेगा सी माइनस ओमेगा एम लोअर साइड बैंड फ्रीक्वेंसी and omega c plus omega m is upper side band frequency. Okay. So note down this first. Note down. This is second page. Note down. Now let's move ahead. See here, I'm drawing one graph. this you will get lower sideband frequency, upper sideband frequency, and all. This graph is amplitude versus omega. So here it is omega c, and this is lower sideband frequency now. So here you will get omega c minus omega m, and this is upper sideband frequency, so omega c plus omega m. Okay. Okay. So if you want modulation index, that is MA, one more formula, K times AM divided by AC, that is change in amplitude of carrier wave, change in amplitude of carrier wave divided by amplitude of original carrier wave. So MA is equal to K times or just AM, anything, AM divided by AC, or also equal to A max minus A minimum, that is change, hai na? Here already I have written, and down A max plus A minimum. So this is what your formula for modulation index. Even you can denote this as a mu also. Okay. And this is when if K is equal to 1. Okay. Now see down. Note down this first. We will solve some problems also on this. Very easy problems. Note down first. Let's move ahead. Now some note points. In the absence of signal, MA is equal to O by A into 100%, and that is equal to 0%. Okay. Next one. Second one. When the signal amplitude is equal to carrier wave, is equal to carrier wave. Amplitude varies from 2A to 0, and therefore here you are getting 2a minus a divided by a, that is equal to a by a into 100. Yes, no? This is equal to 100%. Okay. Next, third one, if amplitude of signal is half that of carrier wave, then a plus a by 2, how much do we will get? 1.5a. Yes, no? And therefore modulation factor 1.5a minus a divided by a into 100, which is equal to 50%. Next, number 4, if 1.5 times amplitude of signal is equal to 1.5 times the amplitude of the carrier wave, then how much you will get? Amplitude changes from 2.5a to a. Yes, no? Right? Yes. So what you should do here? A plus 1.5a, which is equal to 2.5a, and therefore here modulation index or modulation factor, how much you will get? 2.5a minus a divided by a, which is equal to 1.5. And if we are finding the percentage, then this is 150%. Okay, note down this also. So let's move ahead. Now, power. Before that, one more point, that is, if a carrier wave is modulated, write with me, is modulated with by different audio waves, then effective modulation factor M is equal to under root of M1 square plus M2 square plus M3 square plus so on. Okay. And now next one, that is power in amplitude modulated waves. On this, they may ask you problem, power in amplitude modulated waves. AM waves means amplitude modulated waves. Now in AC, what we have learned, power P is equal to phi RMS square divided by R. Agree? Yes, no? So here now, number one, carrier power is equal to, here AC by root 2 is what ARMS we can say. Yes, no? And divided by this R, which is equal to AC square by 2R. Clear? Next one, total power of sidebands. Total power of sidebands, that is P of sideband, is equal to modulation index into AC divided by 2 root 2 whole square divided by R plus MAAC by 2 root 2 whole square divided by R, and that is equal to MA square AC square divided by 4R. This is what total power of sideband. Okay. Next one, total power of AM wave, that is P total is equal to P of C plus P of sideband. So what you will get, Ray? AC square divided by 2R plus MA square AC square by 4R, and that is equal to, if AC square by 2R we are taking common, AC square by 2R into bracket, what you will get? Yes, 1 plus MA square by 2. Okay, note down this. Let's move ahead. Now see, maximum power, next point after that, maximum power in the AM that is without distortion will occur when modulation index is equal to 1, and then PT will become 1.5 times P, which is equal to 3 times sideband frequency, 3 times sideband power. Three times sideband power. Okay. Next point, fractional power carried by, fractional power, if they are asking you, carried by the sidebands, then this is PS by PT which is equal to ma square divided by 2 plus ma square. Next point, fractional power carried by carrier wave is equal to PC by PT, and this is equal to 2 by 2 plus ma square. Okay. You have everything above, you just substitute that, you will get this. Already I told. Here PT you have, PSB you have. Okay, this is PC. And carrier power here, PC. So everything you have, just substitute, you will get this. No need to think more how you got this. Okay, just divide that, you will get it. Okay. Right, shall we solve one problem? Okay. Note down fast. Very easy problems. Noted everyone? Noted? Okay. Let's solve one problem. See here. A message signal of frequency frequency 10 kilohertz and peak voltage 10 volts is used to modulate a carrier of frequency 1 megahertz and peak voltage 20 volt. Then what you have to do? Number one, then find mu, and number two, or you say B, you have to find sideband produced. Sideband produced. Now how to do? See, I'm giving you hint. You can go ahead with that. Given kya hai, message signal you have. Yes. And that frequency also they have given. So F of message signal or modulated signal is 10 kilohertz. So that is equal to 10 into 10 to the power 3, which is equal to 10 power 4 hertz. Okay. And peak voltage they have given. So this is nothing but AM. Yes, that is what 10 volt. Now carrier wave frequency they have given. So FC is given. FC is how much? 1 megahertz. So that is equal to 1 into 10 to the power 6. So that is nothing but 10 power 6 hertz. And AC also they have given 20 volt. Peak voltage means this only. Yes, no? Now mu formula, you know. What is mu formula? Yes. Can you tell me what is mu formula? Yes, tell me. AM by AC. Yes. So you can substitute this directly. So how much you will get? 0.5. This is what your A answer. B answer is what he is asking. Lower side band, that is equal to omega C minus omega m, and upper side band frequency he is asking, that is omega C plus omega m. So what you have to find? 2 pi fc minus 2 pi fm, and here you have to find 2 pi fc plus 2 pi fm. Yes, you have fc, you have fm. You can take out this 2 pi outside and just fc minus fm, and here also 2 pi fc plus fm you do, you will get this upper side band and lower side band frequencies. Can you do it now yourself? Yes, do it. We will stop here. Okay.